Hello, I'm Dr. Harper. This video is a lecture video on aggregate planning and operations management. So let's bring up the lecture notes. Okay, aggregate planning has the input of resources, which is a combination of resources of inventory, of labor, capacity, and the output is a production plan. Now, in the aggregate planning here, there could be a lot of different approaches to aggregate planning. Aggregate planning looks at in different terminology. Aggregate planning looks at the general entire from the beginning to the end, the whole input-output process. Production planning looks at the output, like how much production you have to produce, your production plan specifically. Sales and operations planning is the connection between the sales demand, your operations planning, and so there's three different, slightly different approaches, but I'm putting all that under the umbrella of aggregate planning. So we'll be looking in aggregate planning. We'll be looking at strategies. We'll be looking at characteristics. We'll be looking at applications. Okay. First two strategies are level capacity and chase demand. So let's start with some examples. If you have your demand constant, if you have your inventory and your demand and your capacity and productivity, those four things that you're managing, then if your productivity comes from your capacity, and suppose your productivity is constant, if the demand goes down, the inventory goes up. On the other hand, if the demand goes down, your production goes down, and if it goes down the same amount, then the inventory stays constant. So the relationship between those four things, capacity, production, inventory, and demand, that's what aggregate planning captures and uses to create some very, very powerful strategies. So we will look at start with two pure strategies of level capacity and chase demand. Let's start with an example. Suppose you had a forecasted demand and you have bring it down here. So quarters 1, 2, 3, and 4, you had a forecasted demand. The first quarter, you need to make, the demand was 12,000. You had to satisfy then 28,000, 24, and 20,000. And then in order to produce that with level capacity, an example or a description of a level capacity production plan, PP stands for production plan, and the definitions are down here. Level capacity, chase demand, quarter demand, production plan. A description will be taking your the quarterly demand to get the annual demand. Simply divide that by 4, and you have your production every quarter. And so your annual production equals your annual demand. And that's a description, a simple description of level capacity production plan. But production is not, capacity is not measured with just production. Capacity could be a lot of different things. It could be different types of resource. It could be facilities. It could be equipment. The capacity we look at that generates productivity is labor. And in labor, we will consider something called the FTE, which is a full-time equivalent. Now, one FTE is a full-time equivalent worker. So one FTE would be one worker working full-time over a period, or it could be 2 workers working half-time over the same period, and that's equivalent to one FTE. So a full-time equivalent in aggregate planning will look at FTEs, not workers. So let's suppose we are given a production standard where we relate our capacity of FTE to our productivity of items per quarter. So this production standard relates our capacity with our productivity. 1 FTE capacity equals 200 items per quarter output productivity. So there's our link between capacity and productivity. So when we look at our capacity here, then we say, well, how much capacity do we need with 21,000 units of production? Well, if we had only one FTE, then that would generate 200 items of production. If we had two FTEs, that would generate 400 items of production, but we need to generate 21,000. So how many FTEs do we need? Well, we'll divide our production plan by 200, and that will give us 105 FTEs. And each one of those FTEs will produce 200 items every quarter, and as a standard, and so that will generate a planned 21,000 every quarter. So this FTE is the capacity. So level capacity is defined by your FTEs in this development. So FTEs define level capacity, not production. And we'll see in this lecture, when we begin changing things and modifying things, that the production plan for a level capacity may not be constant, but the FTEs will be constant. And there's different ways of doing that. So this is our labor, and this is our productivity, and this is our demand. Remember, the fourth thing is inventory. So BI and EI stands for beginning inventory and ending inventory. So suppose we have the requirement that beginning and ending inventory is 3,000. We're going to start the year with 3,000, and we're going to end the year with 3,000. Okay, then what's our ending inventory? Well, up here we see that our ending inventory simply is, well, at the end of the first quarter, it's going to be our beginning inventory, which is what we start with. Beginning inventory plus our production, because that production is going into our inventory, minus our demand, because that demand is coming out of our inventory to satisfy our demand, leaving our ending inventory. So 3,000 plus 21,000 minus 12,000 equals 12,000. And then the beginning inventory of the second quarter, right here, simply will be the ending inventory of the previous quarter. And then we do it again. 12 plus 21 minus 28 is 5. And then we do it again, and we do it again. Okay. And so there's our inventory. And so you notice with the FTEs, we got our FTEs from our production plan, and there was the identity. For inventory, we got our beginning and ending inventory, and that equation represents the identity. So these two identities are referred to as equilibrium equations, and making sure that the FTE is accounted for is called conservation of labor, and inventory is conservation of inventory, because whatever labor we have, whatever inventory we have, it has to be accounted for. And that's referred to as conservation of labor, conservation of inventory, and so all the equations taken as a group is referred to as conservation. Well, that's level capacity. Now this is referred to as one pure strategy. Well, the other pure strategy is chase demand. Chase demand, a description of chase demand, again, just a description, simply is, okay, well, let the demand equals let the production equal the demand. So set those equal to one another. So the 12, 12, 28, 28, 24, 24, 20, 20, well, that's a description. But what's the definition of a chase demand? Well, the definition of an aggregate planning strategy is in the capacity. So again, we divide our production by a production standard of 200, and then this gets transformed, the production, the productivity gets transformed to capacity, which is our FTEs. So this is the definition of a chase demand pure aggregate planning strategy. What about inventory? Well, we start with 3,000. 3,000 plus production minus demand equals our ending inventory, but the demand and production, let's bring it back up here, the production and demand are always the same. So essentially, they'll always cancel out, and the ending inventory will always equal the beginning inventory. They'll always be equal. And so we see that, 3,000, 3,000. Okay, so there's the strategies, okay, and this demonstrates the strategies. But now, characteristics. And this is one of the most important things to take away from aggregate planning. And that is, for level capacity, the variability in the demand, and we see variability 12, 28, 24, 20, that's variability. The demand variability is totally reflected in the inventory, and it's not in the capacity at all. So the capacity could be referred to as independent of demand variability, and the inventory is dependent on demand variability. Now, chase demand is just the opposite. The capacity is dependent on demand variability, and the inventory is independent of demand variability. Okay, another way to describe that is that this demand variability is totally contained within the inventory. This demand variability is totally contained in the capacity. And our FTE, the demand variability is filtered out, totally removed from our capacity, and here it's removed from our inventory. Okay, so those concepts and those characteristics will be extremely important when you come to strategies other than the pure strategies, even with pure strategies, and we'll pull out more characteristics in this lecture. So let's go on. So we've talked about, well, when would you use these? When do you use level capacity? Well, one way that when you would use level capacity is you want your labor to be constant. Maybe you have expertise in your labor that's hard to replace. You don't want to lose it. You don't want to change it. Maybe you want your labor to be constant to engender loyalty, commitment. Maybe you want to grow. You want to support your employees and your FTEs and your labor. You want to support them with education. You want to invest in them and so that they can become better and stronger. Okay, and then with chase demand, here your labor is increasing and decreasing, and this is in industries where labor is low-skilled labor, where level capacity could be high-skilled labor. This could be low-skilled labor, and you're thinking of like summer labor, where you increase and decrease just within a season. You have seasonality demand. What about inventory? Well, here, this inventory completely describes demand, and here it's independent of demand. So you could say that we have control over our inventory. We can increase and decrease our inventory. Up here, this inventory is dependent on demand. So whatever this demand is to control inventory, we control our demand. Okay, here, we're controlling our inventory independent of our demand. So there's some and also here, since our inventory is dependent on demand, then our demand will be met out of inventory. This is a push inventory strategy and a make to stock. Well, since the inventory is independent of demand, we can control inventory. This supports more of a pull inventory strategy and make to order. And we'll see how that plays out again later in this lecture. So we looked at characteristics, we looked at strategy, we looked at equilibrium equations. One thing we haven't looked at is cost. So let's look at our objectives. Let's do objectives, let's do cost. So an objective, let's look at an inventory objective. We can achieve different objectives within aggregate planning. For example, suppose the beginning and ending inventory of 3,000, that's eliminated. And that's replaced with the beginning annual inventory is 3,000, but we want to include an inventory objective of increasing or decreasing the ending annual inventory, so this is an inventory objective. So let's look at example number 1 here, level capacity. Suppose our inventory objective was we want to begin with 3,000, but we want to end with 3,800. In other words, we're going to start here at 3,000, we want to end with 3,800. That's our objective. So this is our level capacity that we just looked at. So how do we create a level capacity with this inventory objective? Well, there's different ways of doing it. There's different approaches. So first of all, we look at this and say, okay, one way is we want to increase the ending inventory by 800. So we can take this 800 and put it down here in the annual production and say, okay, this is level. So let me just take 84,000 for our demand, 84,800 for our annual production, divide that by 4, and there's our production plan. Divide this by our production standard of 200, and there's our capacity. Another way is saying, okay, well, let's take this 800 that we want and divide the 800 by 4, which is 200, and spread that evenly throughout the year. Divide that by 200, we have our FTEs. A third way is taking the increased inventory of 800 and dividing that by a production standard of 200. Well, 800 over 200 is an FTE of 4, but this is a quarterly FTE standard, so therefore this represents 4 quarterly FTEs. So we want to increase our capacity by 4 quarterly FTEs. We spread that evenly, and so the 105 spread the 4 evenly, so it's 1 every quarter. The 105 becomes 106. We multiply that by a standard to get our production standard. We sum to get our annual. So there's 3 different ways of doing this. Now the reason I mentioned all 3 ways is because in some applications, one way may be preferred over another. Okay, but once we have our capacity, our quarterly productivity, or annual productivity, and there it is, then we can create our inventory here, 3,000, plus our production minus our demand is our ending inventory. Carry that as our beginning inventory. Do it again, do it again, do it again. So now we can see, oh, okay, well, since I have 200 more, notice my inventory here is 200 more than it was before. But by the time I get to the end of the second quarter, it's 400 more than it was because I've done 200 twice, and then 600, and then 800. There's my objective. Now, why would a company want to do this? Well, in anticipation of an increase in demand, you want to make sure you have your inventory because you don't have time to produce those items. For example, in areas of the Olympics coming to town, you know there's going to be an influx of demand in all the retail stores. They need to increase their inventory to satisfy that demand. Or events that are coming to town, like a national convention of some kind. You know there's going to be an increase in demand. Increase your inventory to satisfy that demand, because once it happens, you don't have time to increase your inventory, so you do that beforehand. So that's a very good reason why you would have this inventory objective. So let's go the other way. Let's look at chase demand, and let's decrease the ending inventory by 800. Okay, so well, when we have chase demand, remember the chase demand is defined by our capacity. So if we want to change our capacity, again, we'll take this 800 divided by our production standard, which is 4 quarterly FTEs, but it's a decrease of 4 quarterly FTEs. So we will spread that decrease throughout the year and subtract 1 FTE every quarter. So the 60 becomes 59, 140 becomes 139, 120 becomes 119, 100 becomes 99. So this then becomes our chase demand strategy with an objective of decreasing our ending inventory by 800 or decreasing our FTEs or quarterly FTEs by 4 over the year. We multiply that by 200 to get a production plan, and we sum to get an annual, and then we do the same thing for our inventory. Now notice I went through this is a chase demand strategy with an objective, and this is a chase demand production plan with a strategy. With the inventory objective. But notice in this case, our demand and production are not equal. So what defines chase demand? It's the FTE. And how does the FTE chase demand look? Well, the variability in the demand is completely contained in the capacity of FTE. That's a chase demand strategy. Now, you can have different objectives to where the production may not be exactly the same, but this structure, the pattern in FTE, is dependent completely on the demand. And the inventory is totally independent of the demand. But notice it's not constant, but it goes down 2,800, 2,600, 24, 22. It goes down linearly, and it doesn't really reflect the demand here. This change in the inventory reflects our objective, not the variability in the demand. Okay, why would anyone want to do this inventory objective? Well, there's a number of ways of doing it, a number of reasons. One of the biggest reasons is, well, these FTEs are saying, okay, I'm producing all I'm generating all this production, meeting our demand. They look behind them and say, all this inventory is not really being used. This inventory is expensive. Inventory is expensive. So why not reduce our inventory if we don't need it? Because why are we carrying all this inventory when we really don't need it? Good point. So we could reduce this to 2,200, and if this is 2,200 all year, we don't really need 2,200. We could do it again to 2,000 or 1,800 or 1,000 or 500. So theoretically, if our capacity, if our FTEs, if our labor can meet our demand perfectly with no uncertainty or no risk, then theoretically we could reduce our inventory to zero. Now, if we have zero inventory, what type of operation is that? That's just-in-time, JOT operation, and that's a pure make-to-order type aggregate planning strategy. So, chase demand allows you to move toward make-to-order, and level capacity can lower cost with chase demand. Okay, and so usually make-to-order is more service-oriented, and level capacity is more cost-oriented, and that is used within supply chains. And that's the objectives within supply chains. Okay, so that's some of the insight here. So again, we've looked at objectives here. So now let's move on and look at cost. Cost of labor. Remember, we're looking at just labor and inventory with FTEs and inventory levels. So if we're looking at cost, the first thing we do is define unit costs, and then the total cost for inventory. And we're going to divide labor up into hiring and firing. Now, I'm using hiring and firing as just descriptive terms. It doesn't mean we hire people and fire people. It means hiring is increasing our FTE, firing is decreasing our FTE. Remember, an FTE represents maybe one person working full-time, 2 people working half-time, 4 people working quarter-time. And so we can just decrease the FTEs, not by firing people, but just decreasing and increasing FTEs. Okay, but I'm using hiring and firing as descriptive because it's easier to follow. So let's talk about some unit costs. Well, the big C stands for cost. The little c here is carrying. The little h is hiring. And the little f is firing. So the unit cost here is $9 per item per year, $150 per FTE that we hire, $250 per FTE that we fire. And this $9 per item per year, notice it's per item. Also, it's over time. How long do you carry that inventory? But hiring and firing is just an event. Carrying cost is an event over time. Okay, expand that to, let's say, a year, and the total carrying cost, which I'll abbreviate TCC, is your average annual inventory times how much it costs you to carry each of those items over the year. The total hiring and firing cost over a year is how many you hire and fire over the year times how much it costs you for each of those. So this right here represents the total cost. If I add all 3 of these, it's the total cost for aggregate planning. So let's use these definitions here, and let's analyze level capacity with these costs. So I'm going to bring the hiring and firing down here. I'm bringing the carrying cost down here. Here's my equation of my total cost here. And I'm also copying my production standard to make sure we have that. Okay. So now this solution now I'm defining some tables. This solution table, this table right here, came from the very first page. Actually, let me just go back and show you. The very first page, page 1, this table here for level capacity, I'm copying this down. I'm calling that my solution table. I just copy it down to here. Now, the reason I call it a solution table is because this is really a description or a solution of level capacity for this problem. Because remember, for these per strategy, we said, well, demand, production, capacity, and inventory. So this is the minimum amount of information to define this level capacity strategy. And to solve for a level capacity strategy, this is the solution. So this is a solution table. So we sum the demand, sum the productivity, the production, and average the inventory. And there it is. Okay, now, the second table down here is an analysis table. Now we're looking at a tiered or hierarchical approach to aggregate planning. Now we're going to analyze this table. We could analyze it many different ways. This first analysis will be a cost analysis table. It could be an environmental analysis, a risk analysis, all different types of analyses. But we will just look at a cost analysis as an introduction to aggregate planning. Okay. First of all, we're going to look at cost of labor and inventory. Okay. First of all, labor. Notice our FTEs is just 105. Bring these down. Well, there's 0 hiring and firing because we don't really change anything. So that's 0, 0. We bring down a unit cost, and hiring and firing is 0. Well, that's easy. When you have a pure level capacity, hiring and firing is 0, and that could be considered a property. That's how things work. Okay, but there is inventory. So we bring down our inventory here. We average all year. So our annual average inventory is 5,500. Each one of those over the year cost $9 to carry, so $49.5 is our total carrying cost. We add those three together, and there's our total carrying cost for level capacity. Okay, but notice there's 3 more columns here. There's more calculations and more numbers, but the whole reason for this is determining the carrying cost per quarter. Well, down here, I determined the carry cost per year, and that's all we were looking at. But you could also analyze this in more detail. Well, what's your carrying cost per quarter? Well, it's more work, it's more numbers, but it's more information, and there's more control over your level capacity strategy. So let's do it. So first of all, the average inventory. This average inventory is average inventory per quarter. Well, 3,000 plus 12,000 divided by 2 is 7,500. I do that for each quarter. My carrying cost here over the year is $9. But then if I divide that by 4 over each quarter, it's $225. So each one of those items is cost $225 to carry throughout the quarter. So if I multiply those, I have my total carrying cost per quarter. And if this is my total carrying cost per quarter, I add that up. That's the annual carrying cost. These two numbers here must be the same because it's the same arithmetic. It's just done in different orders. Okay, why should we do this? Well, the reason we do this is that we can tell what the cash flow is throughout the year in our inventory. So in our warehouse, material management, they say, okay, what's our budget? Well, unfortunately, what happens in a lot of companies, if you see the annual carrying cost of $49.5, the budget then will be this divided by 4 because there's 4 quarters in a year. But if let's just round this up to 50,000 divided by 4 is only 12,500. If we budget an equal 12.5 every quarter, notice the first half of this year, our cost is going to go over budget. The last half of the year, it's going to be under budget. But then if we just have a 12,500 level budget, then our costs in our warehouse, material management, will not equal that budget. You'll be over the beginning of the year, first half of the year, you'll be under last half of the year. And what happens is the vicious cycle of if you're over, will increase your budget, if you're under, will decrease. And no, this is analysis. Aggregate planning analysis says this is my budget throughout the year. 16,875, 19,125. So now you have a more precise budget and you can manage your operations within your warehouse much more detail and much more responsibly, and you know how to manage your funds, your cash flow within your inventory. Okay, so let's take this analysis and let's look at chase demand. Okay, now we have a chase demand. Okay, again, I copy the solution table from above, and there it is. And now, when I start analyzing my labor, I bring down my FTEs. I bring them down here, and there they are. Now, they're increasing and decreasing. Now I have hiring and firing. So follow this logic. In the first quarter, I have 60 FTEs on board doing work. At the end of that quarter, I end with 60 FTEs. The beginning of the second quarter, I want to start with 140 FTEs. So at the beginning of this quarter, second quarter, I have to increase 60 up to 140, which is an increase of 80. So I'm hiring 80 at the beginning of quarter two. At the end of quarter two, I have 140. I only need 120 at the beginning of quarter three. So I'm decreasing this by 20. So I'm firing 20 at the beginning of the third quarter. Likewise, the beginning of the fourth quarter, it goes from 120 down to 100. It's firing or decreasing my FTEs to 20. And at the end of the fourth quarter, I have 100 FTEs. Well, what quarter happens after the fourth quarter of every year? The first quarter of the next year. Okay, well, we're assuming this is a steady state analysis. So at the end of the fourth quarter, we have 100 FTEs. The beginning of the next quarter, we only need 60. So at the beginning of the first quarter of every year, we're going to fire 40 or decrease our FTEs by 40. So this is a steady state analysis. In other words, steady state means every year is the same. So we're not doing this for just 1 year. We're doing this for every year into the future. Okay, so it's a wraparound. Okay, when I add my hire and fire here, notice there's 80 and 80, and the reason they're 80 and 80 is because the annual production equals annual demand. Okay, and so if this is true, then your hiring and fire will always be true, will always be equal. If this is equal, this is equal, and then you multiply. In this case, you multiply by unit cost, and there's your hiring and firing cost. So now when I bring down my inventory, notice my inventory is constant because it's chase demand, because all the variability is in the labor, not the inventory. And so it's all level. And so the average is 3 times 9 is 27. We add this 7, we have 59. So again, I'm going to take my average inventory for every quarter. I get 3,000 times my unit carrying cost of 225. And now I do have a constant total carrying cost throughout the year. So when you take your 27,000, divide that by 4, and you have a constant forecasted cost and cash flow within the year, that's assuming a chase demand strategy, because a pure chase demand strategy will result in that. So again, here is an example of people mismanaging. In other words, they'll say, okay, well, up here, if you have 49.5, then we'll take that and have a budget which is evenly distributed throughout the year. And the aggregate planning or the operations manager who knows operations, who knows businesses, will know we have a level capacity strategy. And it's a pure strategy, so this will not be level. This will not be constant. It'll be variable depending on the variability in the demand. And if you don't understand this, that doesn't make any sense to you. And so quite often when you have people doing the budget who do not understand operations management and aggregate planning, they have no idea what that means. They say, well, I don't know what you're talking about, so I'm just giving you this kind of budget for this type of strategy. It's level, but I'm giving you a level. If it's a level capacity, we're just going to give you a level budget. And you say, no, a level budget assumes a chase demand strategy. So here's the idea. If you have a constant budget, level budget, then essentially that assumes that you have made the decision of a chase demand strategy before you get to the budget. And so quite often in companies, people make decisions, and those decisions are disjoint from other decisions they've previously made. It says that doesn't follow. That doesn't logically follow. You're going to increase a disjoint, and that disjoint will create costs, inefficiencies, and mismanagement. Why? Because people don't coordinate. And that's why you need business people doing business. Okay, another point here. Suppose that our unit cost changed. Suppose, let's say our carrying cost. Suppose our carrying costs began to increase, and sometimes our warehousing cost increases, logistics increase. Sometimes it does increase. Okay, suppose this $9 goes to $19, goes to $90 per item, $900. Suppose our carrying costs were prohibitive. It was like $9,000 per item. Oh my goodness, wow, if it's $9,000, then which one of these pure strategies would that move you toward? Well, first of all, the average inventory is $5,500 for level. The average inventory is only $3,000, so an increase of the carrying cost here would impact the inventory with chase lower than level. But more importantly, remember the characteristic of, since the demand variability is independent in the inventory, we can control inventory. So as this carrying cost increases, we can go to chase demand and decrease our inventory levels. And if we theoretically decrease this to zero, we don't care what this carrying cost is because we're not carrying any inventory. Everything is make to order. So moving to make to order will disengage the reliance on increasing carrying cost. Again, aggregate planning strategy. And that's extremely powerful in the hands of an operations manager who has the power, the knowledge, and capability to do that. So you can absorb different costs, external costs that are coming at you in aggregate planning by modifying how you operate in the solution analysis table. Okay. Now remember I said moving between level and chase. Well, level and chase are just two strategies, and they're pure strategies. What are strategies between these two, are moving apart away from these, moving from one to the other, and I call that a mixed strategy. And actually our textbook uses the term hybrid, a hybrid strategy. And hybrid, mixed, I use mixed, they use hybrid. It doesn't matter what term you use, what's important is know what it is. Okay, first of all, let me illustrate, like I've done before, let me illustrate what a mixed strategy plan would be. Assume an arbitrary mixed production plan. This is arbitrary. And I picked 19, 19, 23, 23K. Okay? But even though this is arbitrary, I did pick these four numbers such that they satisfy three conditions. The first condition is kind of obvious. It is these three. This production plan is not level and not chase. That's the first condition. That's obvious, but you got to state it. The second condition is I wanted my annual production to equal my annual demand because I wanted this to be a steady state analysis. The third condition, which we will do in this development, in this lecture, is no negative inventory. Now the inventory can drop to zero, that's fine, but no negative inventory. We don't want our inventory to go negative. So that third condition doesn't always happen. Sometimes you do have negative inventory. If you have negative inventory, then you have something called back orders, you have stock outs, you have different buyouts, you have all different ways of handling negative inventory. So in this lecture, in this development, I'm focusing on aggregate planning, not inventory strategies, aggregate planning strategies. So I'm requiring no negative inventory in this development. You can change. We will change that later. Okay, But then I'll take this production plan, this solution table, and I'll do my analysis. Now, I'm not going to go through this again. I'm going through this where I'm combining the hiring and firing and the inventory. And so I'm going through the very same steps I did before. But I'm using this analysis table to introduce a third table called a comparison table. A comparison table. Now, this comparison table simply says, okay, I'm going to pull down, let's say, my production FTEs and total cost for my level, for my chase, for this mixed or hybrid plan, and I want to compare them. Well, this is aggregate planning, and here in the comparison table, here's where planning happens. And so here's where you bring to the table, bring to the planning committee. Today we're looking at production and labor. Notice what's not here. Inventory is not here. Unit costs are not here. So maybe we're going to analyze that. What about risk? We can analyze risk. But the comparison table says we're just focusing on labor and total costs. Okay, at this point, let's look at this a little bit. Look at the total cost. Very interesting. Right here, this is something that, let's shade this in. We're going to be looking at the total cost here. Wrong one. This one over here is what I want. There they are. Okay, let's look at these total costs. Now, let's go down one, and let me just increase this to just round this up to 50K for discussion purposes. Round this up to 60K for just discussion purposes, and round this up to 40K for just discussion purposes. Okay, and here's the discussion. Okay, well, this is the same demand. It's 3 different production plans. With level, chase, and mix, the only thing we're changing is our production plan. That's the only thing we're changing. And by changing our production plan, we're changing when we have our people work. Is it level? Is it chase? Is it mixed? When we have them work, we're just changing how we're doing things internally, just on how we deploy labor. But notice the differences. Well, 50,000, 60,000, this is $10,000. 60 to 40, that's $20,000. Well, $20,000, if we're working with a chase demand strategy here, we say, wait a minute, we can just have everything the same except change our FTE load to this, and we can lower the cost by 20%. Or we can lower our cost of planning and production by 20%, 60 down to 40. That's significant. People will spend millions of dollars to decrease their costs by 5% and 10% by not even spending anything, just changing how you do things, working smarter, not harder. You can lower your costs by 20%. And that's why people look at aggregate planning. Well, let's take that a step further. This was an arbitrary plan, right? Well, could we create a plan here that would minimize this cost, that would minimize the actual total cost? Yes, we can. So now we can look at a level plan, chase plan, arbitrary mix plan, and an optimal plan where we minimize cost. To do that, we will use a minimum cost plan, linear programming. And we'll use Excel to do that. So now we're using Excel. And by the way, this ends what I call level 1. This is level 2. We're moving into level 2 of aggregate planning strategy. Let's create the minimum cost plan using Excel, using optimization. So here I brought down, just to illustrate it here, I brought down my production plan. And there's the FTEs. Here's a hiring and firing. And there's a beginning and ending inventory. And here's my cost down here. So what I'm going to be doing here is saying, okay, well, I want to change my production or change my FTEs, either one, such that my total cost is a minimum. How do I do that? Well, here's how you formulate it. First of all, zero these out. Here's your demand. At this point, we say, okay, well, we are going to change we're going to change our production plan, hiring and firing, but we want to have our FTEs here. Make sure that we have our conservation equations with FTE with right here. That's conservation of labor, and I'll go over that in a minute. And here's my conservation of inventory. Make sure these are tied together. And then once they're tied together with our production over here in hiring and firing, then we can minimize this. Okay, now this is just a description. This is not showing you how to do it. This is an outline of how to do it. But instead of just talking about these things, let me actually show you how to go back and do this in Excel. And so to get this solution down here. So let's just do this in Excel. Okay, so let's bring up Excel. Okay, in Excel, I'm going to take my demand here. Well, first of all, let's come up here. Let's come down a ways, down to here. Here and say my beginning inventory, and type this in. Beginning inventory equals my ending inventory equals, and our projection standard equals. Let's enlarge this so we can see it better. Okay, our beginning inventory is 3,000, ending inventory is 3,000, production standard is 200. Okay, and then down here we want our quarters. We want our demand. We want our production plan. Okay, and then let's just put our quarters in. 1, 2, 3, 4. Our demand, type this in: 12,000, 28,000, 24,000, 20,000. Okay, or I could have copied this and pasted it, but I'm doing it this way for now. Okay, now that we have this, the next thing is bring this over here. Okay. Okay, then we're going to have our production plan here. Well, what I'm going to do, let's enlarge this so we can see what's happening here. This is good enough. Okay, then we have our production plan. And then here, let's just say we have our hire here. We're going to have our fire. We have our FTEs right here. And then we're going to have our left-hand side. This left-hand side is going to be our conservation equation, equilibrium equations. We have our beginning inventory, and we have our ending inventory. So let's start filling this in. Okay, first of our production, well, that's simply going to equal our FTEs times our production standard. You know, I'm gonna put this in here. Let me put my production standard in here. Why not? That equals 200. Let's just put this in here. So put everything in the table. So now our production plan is going to equal whatever those FTEs are times our production standard. And then copy that down. Okay, we don't know what our FTEs are yet. As a matter of fact, the hiring and firing in FTEs, let's box this in. Boom. And then let's shade this a little bit because this will be our decision variables. We want to change these. Okay. And here's our production. Now the left-hand side. Now on this left-hand side, I'm going to be using this equation right here. And let me just explain it. Okay. Let's start with the second quarter. Now for the second quarter, here's my FTE for this quarter, and the FTE in the previous quarter is here. Now let's suppose this is 10 and this is 20. Okay. Then right here, I want to hire 10, right? Now what if this? So therefore, in order for this previous FTE and the current FTE and the hiring and firing to be equal, then what I'm going to be doing is I'm going to say, let's justify. I'm going to say equal my FTE in the previous quarter, but in this quarter, this is going to equal, I'm going to add what I hire. I'm going to subtract what I fire. That's going to equal my FTE. But if I bring it over to this side, then I'll subtract whatever that is. And notice it's 0. So I essentially want that on every single one of these. Okay, now let me just delete these. Now, the previous FTE here is the fourth quarter FTE plus what I hire in this quarter minus what I fire minus the FTE in that quarter. So there's my equilibrium equations that I want all these to be 0. That means from quarter 1 to quarter 2, 2 to 3, 3 to 4, 4 to 1, they're all going to either hire or fire, they're all going to be equal. Now our beginning inventory simply equals our beginning inventory there. Now our ending inventory equations, again, I will take the equilibrium equation right here and increase that again. Okay, equals our beginning inventory plus our production, here's our production, minus our demand, that's our ending inventory. And I can copy that all the way down. The beginning inventory equals the ending inventory, and copy that all the way down. And there's our setup. We have our labor, we have our inventory, we have our production. Now we come to our costs. Okay, so let's type our costs in. Our unit cost here for hire is $150, fire is $250, and inventory is $9 per item per year. Okay, so let's put this over here. The cost of hire equal the cost of fire equals, and the cost of inventory equals. Okay, and let's make sure we get these right. It's 150, 250, and 9. Okay, we can do that. This right here is 150, 250, and 9. And there they are. Okay, so right here for the hire and fire, we want a sum equals a sum. Like how many are we hiring over the year? How many are we firing over the year? Whatever it is, the unit cost equals 150 for hire equals 250 for hire. Our total cost equals how many you hire times the unit cost, and copy that over. So there's going to be the total. This is the total hiring cost and total firing cost. And there they are. Over here on inventory. Okay, let's move this over a little bit. On inventory, we want the average. And we take the average to be safe from the very beginning, the ending average of all, beginning and ending everything. Okay, and then the unit cost equals the $9 per item per year. And then the total cost equals the average times 9. And there it is. So now this is my total carrying cost. And there it is. Very good. Okay, now what I want to do is my grand total. I could put it over here. Let's see here. Yeah, let me put it over here. I want the grand total cost. Okay, and that's simply going to equal our total carrying cost plus the total firing cost plus the total hiring cost, and there's my total. Now let me box that in and shade that, because that's what I want to minimize in my linear program. And there it is. Okay, so now I have everything set up. It's ready to go. So let's go to data. Let's bring solver down, and there it is. So now right here, I want my objective function to be this right here. Click L13, and there it is, L13. I want to minimize the cost by changing these variables right here, my capacity. Changing my capacity. Here's my capacity. Here's the increase and decrease of my capacity. I tie that into my production through the production standard. So I'm good to go. Now I add my constraints. And my constraints are, first of all, my left-hand side here has to equal 0 to make them all equilibrium equations. Add. The ending inventory, all of these have to be greater than or equal to 0. We don't want negative inventory. No negative inventory, remember. Add. And finally, the ending inventory here, we want that to equal our ending inventory of 3,000. Say OK. And so, in other words, we want to make sure that we begin and end with 3,000. So I could have, by changing that number, I can have different inventory objectives here, like I did at the beginning of this lecture. OK, non-negativity constraints. We want a linear program. Whoops, because it is linear. And then solve. And sure enough, solver found a solution. All constraints and optimality conditions are satisfied. Keep solver solution, yes, OK. And there's my 37,750. And if I look back, my solution down here is 37,750 with the 1324. Let's bring this back. My production plan, 1324, 24, 23, 1324, 24, 23, and that's the solution. And there it is. So that's how you solve this thing. So this is just an introduction to level 2. Okay. But then once we have that, then we can come down and actually compare them. And now I have 30. Well, actually, the 39.5 was pretty close to 37.750. This is optimal, and it's mixed. It's not level or chase, so it's mixed. And this is, and there's no negative inventory, so this is optimal. It's pretty close to the mixed. It's pretty darn close. Okay. Notice what I'm saying here. You can take this. You can take the this minimum cost here. You can take this and what if we wanted the cost of a level plan? So how would we do that? Well, you could take the solver here, and you can add a constraint. Then you want all the hiring and firing. You want these to equal 0. Because remember, if you hire and fire nothing, that's going to be level. Say solve, and there's my level plan. And there it is, 49.5. Okay, or you can take that off. Up, where would it go? Let's see here. We want FG of 11. FG of 11 here. Let's delete that, and then go back to our minimum. And there it is. Now, if I wanted to chase demand, what's chase demand? Well, the chase demand simply is going to be we want to add a constraint where all of our production here is going to equal our demand. Okay, solve. And now we have our chase demand, 59K. There it is. Okay, and let's go back to where we did that. And then delete that, and then solve it, and we go back to our minimum. So my point is, once you have this set up, if you understand the characteristics, then you can have different types of plans. Okay, I call this my level 2. My level 2. Now level 3, relationships and definitions. So let's introduce, let's go a little bit deeper. I've used time standards, FTE time standard. Now this time standard, 1 year is 52 weeks, 12 months, 4 quarters, 1 week is 40 hours. This is a time standard I'm using in this development. Well, that's not always true for every organization. Like some people, the year is based on 50 weeks because 2 weeks out of the year is vacation. So 2 weeks is not productive. Okay. Or some people don't use 12 months or 4 quarters, they use 3 quarters. A university, their fiscal year is 3 quarters. Sometimes they don't work on a 40-hour work week, they'll work on a 30-hour work week or a 50-hour work week. So there's different, but this is a time standard we're using in this development. So it can change. But this time standard then will translate to an FTE time standard. Well, then what is one FTE equivalent output? Well, remember we had 40 hours a week times 52 weeks in a year divided by 4 quarters. So this is 520 hours per quarter. Well, 40 times 52 would be hours per year. 40 times 52 divided by 12 is hours per month. So you can have time standards for different quarters, months, weeks, whatever, or years. But then this relationship holds for something called a production standard. That's what we've been using. And then a labor standard. So let me introduce a labor standard to go deeper into the actual management of the labor, human resource management. Well, production standard, we're given this, but then a labor standard, suppose we have a labor standard of 2.6 hours per item. Now, the production standard says, well, 1 FTE will generate this much production in your operations, but a labor requires 2.6 hours to make each item. So notice this is items per time, this is time per item. This is how many items an FTE can generate, and here's how many hours is needed for each item. So the difference between these is that the production standard is usually for top-down planning, looking at how many FTEs we need. The labor standard is bottom-up worker efficiency, like how can we make each item be produced more efficiently. You focus on the labor efficiency. So it's top-down, bottom-up type analysis. But these go together within your production standard by your FTE time standard. Let's bring the time standard down per quarter. Bring the labor standard up, and that gives us a production standard per quarter. And so the production standard equals FTE time standard over labor standard. So that's an identity. That right there, let me bold that. That's an identity. The production standard, PS, equals the FTE time standard, FTE time, divided by labor standard, LS. Okay, so that's a standard that we'll be using. Well, we'll use that when we go to the next development, which is aggregate planning with overtime. Okay, so let's look at chase demand with overtime. So we go back to the original problem here, and we have 3 requirements. First, we want to chase demand aggregate strategy. Fine. We go back to the very first page back here, page 1, and we bring this chase demand down. Okay, right down here. And so we bring down our demand, our chase, and this is chase demand production plan. Okay, and there's our FTE requirements. So okay, so this first one here, let me just do this, and let me bold this, make this, box it in. So this first one here is the chase demand strategy. Okay, so that is chase demand. So now we're going to start with this, but we're going to modify it. But we started with chase demand, so we will call it a chase demand strategy. The next is very commonly you say, okay, wait a minute. We have a maximum FTE per quarter of 115. So this is common. You don't have unlimited labor pool. You have a limit on how much labor you can use sometimes. And suppose our limit is 115. Well, when we look at our FTEs that are required here, 61, 41, 2100, the first quarter of 60, the fourth quarter of 100, that's less than 115, no problem. But the second and third quarter then, they have to be reduced back down to 115 because that's all we have. We don't have more than 115 FTEs per quarter. That's the max. Okay, so now the 115 then becomes our actual FTEs. That's actually what we're using. So if we multiply that times our production standard of 200, then this becomes our production. And let me just box this in. That satisfies our maximum FTEs. So now that production plan, the RT is called regular time production. Regular time because these FTEs are working the regular time of 40 hours a week. 40 our FTE time standard, 40 hours a week, over a quarter. Those are regular time production plan. Okay, and but when we add our regular time up, we notice that our annual production does not equal our annual demand. So overtime is allowed. So how do we make up this difference between 78,000 and 84,000? How do we make up the difference? Well, we can do it outsourcing, we can do it contract labor, but suppose we did it with overtime. So let's take the 84 minus 78, and that 6,000, let's box this in, that 6,000 is an overtime production. So we're going to satisfy the discrepancy, the difference here with overtime. So this third box satisfies the overtime. And now the 6,000 overtime plus the 78,000 regular time equals the 84,000 of our demand. So now there it is. Now notice I didn't box in the overtime production per quarter because the way this is spread out, we could do that any way we want. And the way the overtime production is spread throughout the year, I'm saying that is a description of the characteristic of our chase demand aggregate planning strategy with the max FTE requirement and overtime. So this really just represents a different strategy. Oops. There we go. Just different strategies. I want to take this right here and let me shade this in a little bit. Okay, so this is different. This is arbitrary. We can change this around. Well, notice what I said here. It says, well, I want stable inventory. So I want a characteristic of having stable inventory down here. Well, if I want stable inventory, all that means is I want my production here to equal my demand. Well, the regular time does not equal my production. I mean, my regular time production does not equal my demand. But in order to equal my demand, I'm going to take my demand, I'm going to subtract my regular time, and that'll give me my overtime. So 12 minus 12 is 0, 28 minus 23 is 5, 24 minus 23 is 1, 20 minus 20 is 0. Now, when I do that now my production, my regular time plus overtime equals my production, my CD, my production plan. That equals that. Now my inventory will be stable, level, constant in this case. Now the hiring and firing obviously comes from my actual FTEs, not from the required, because that's not going to happen. This is the FTEs that I'm actually hiring and firing from. Okay, so 6115 is 55. This is 0. 115 down to 100 is 15. 100 down to 60 is 40. Okay, so that's the overtime for stable inventory for chase demand. But let's analyze this a little bit more. Say, okay, again, people will say, wait a minute, right here in second quarter, I have 5,000 items that I'm making in overtime. But I have 3,000 items over here in inventory that's just sitting there doing nothing. Why not use your inventory? Good question. Inventory is expensive, and I'm paying my people more money to make items that my inventory could satisfy. Good point. So why not use inventory? Instead of paying money to carry that inventory, paying money to make items, that's waste. Okay? Well, let's do that. But actually, let's go the distance. Let's say, okay, well, let's use any time we have overtime, and at the same time we have inventory, let's use all the inventory we can to satisfy our overtime. To satisfy demand instead of overtime. Okay? Well, right here in the second quarter, we can see we're 5,000 items and 3,000. That 3,000 can be used to satisfy demand instead of the 5,000. If so, then down to here, that 5,000 then, if 3,000 is going to satisfy demand, my overtime is just 2,000 then. And if it's 2,000, then that 3,000 at the ending inventory for that quarter is 0, because that 3,000 went to meet my demand. And then the 3,000 inventory plus 2,000 overtime equals the 5,000 I needed. And there it is. But that 0 carried over here, so for the third quarter, I have 1,000 in overtime, but I don't have any inventory. So that 1,000 is going to stay there. But now we come to the fourth quarter. What's happening in the fourth quarter? Well, in the fourth quarter, I have a requirement that 3,000, I'm starting with 0 and ending with 3,000, but I must have 3,000 at the end of the year, because again, that is a requirement up here. The beginning and ending annual inventory is 3,000. So therefore, I have to have 3,000 here. So I need to produce 3,000 more, because if this is, let me zero this out. If this is 0, okay, then I'm not going to have enough production to end my inventory of 3,000. So I need 3,000 somewhere. Where do I put it? Do I put it in regular time or do I put it in overtime? If I put it in regular time, that would change the FTEs, and that would no longer be a chase demand strategy. So I have to put it then in my overtime. So I put it here in my overtime, because my overtime production, this satisfies my overtime. If I put it here, my overtime would be 3,000. My regular time would be what, 81,000, and that would violate my requirements of chase demand up here. Okay. So therefore, there's my overtime. Okay, now let's look at this a little bit deeper, even deeper. Well, when you look at this, you're comparing these two. Oh, also, what are the costs? And I do this in the homework. If the record time unit labor cost is $10 an hour, I pick 10 to be a nice round number. That's our wages. We're paying our people $10 an hour to work. Okay, and the overtime is time and a half. Well, it's time and a half, but it's really 50% more that we're paying them. So it's time and a half because we equivalent say, okay, we're giving them 50% more time than the time they work. So they're paying them 50% more. Time and a half, which is $15 per hour. Then, for a labor standard of $2.6 hours per item, but each one of those hours regular time costs $10, then the regular time per unit production cost then is $26, because it's 2.6 hours per item, and every hour costs $10, so every item costs $26 to produce. So the regular time could be expressed in cost per hour, or the regular time could be expressed as cost per item. Now the overtime is time and a half. Okay, so therefore it's $39 because it's 2.6 hours times $15 if you're working overtime. Therefore, the total direct, I call it direct labor cost, direct labor meaning there's no overhead or any type of cost other than just direct labor cost, just salaries, can be determined for regular time as 26 times 78,000. So that's how each of those items cost $26. So that should be, what is this going to be? 2,028,000. Overtime is 39 times my overtime is 6,000, which is 234,000. So there's my direct labor cost for regular time and overtime. And I'll be using that to analyze the two different costs. Okay, but probably if this was my company, I probably wouldn't use this because this is too costly. I probably wouldn't use this because 2 quarters out of the year it goes to 0, and the risk of running out of inventory and not meeting demand is extremely high. So the risk, and if you run out of inventory, if you have demand, unmet demand, don't have inventory to meet your demand, that's called stock out. Zero inventory does not mean stock out. It means you have unmet demand that can't be met. That's stock out. So the risk of stock out, which is costly, is too high here. The carrying cost of inventory is too high here. I probably want something in between. How would I do that? I would change my overtime. Okay, so that's my inventory. The other is my labor. Well, there's a rule which says if this overtime is seen by your labor as a benefit because I can make more money working overtime, then this benefit goes from 0 to a lot, to a little, to 0. When you increase and decrease benefits significantly, then when you go from 0 to 5,000, people see that as a positive input to their income. Okay, it's something that they deserve because they're working. But when you take it away, you don't give the option of working overtime. That becomes a negative to the organization. When it goes to 0, then that's even more negative to the organization. So when you go up, they see it as a benefit to them. When it goes down, when it goes down, that's seen as a negative to the company. In other words, the increase of satisfaction does not, when you decrease it back down to 0, it doesn't go back to the satisfaction they had before they had the increase. It goes up and it's lower, goes up and it's lower. And so with this type of pattern of increase, decrease, increase, decrease, it begins to lower the morale of the workers that my company gives it to me, then they takes it away. If they give it to me, oh good, take it away, that's bad. It doesn't go back to before the labor had the benefit to begin with. So by leveling out the overtime, then this is seen as a positive, and that positive remains there. It's not taken away. So when a company gives a positive to labor, the labor see that as good for them. To them, they deserve it. When it's taken away, it's seen a negative to the company that took away something that I should have. So leveling out this overtime is a positive labor impact. So we have inventory impact, we have labor impact, and so the combination of those with overtime, and that's why people use overtime, because then they can use that for inventory risk and also risk of labor. Now I did the same thing down here with overtime with level capacity, and essentially it's very similar arguments, but it's a different type of strategy. The level overtime instead of level inventory is level overtime. Here, minimum inventory again, and notice the overtime is not level. Okay, and also notice here when you have your chase demand here with this type of pattern for overtime. Notice in this case our chase demand production plan does not equal demand, but our labor then does have the pattern of chase demand with modifications. Likewise down here, our level capacity here, when we have our overtime is not necessarily level, then our level capacity production plan is not constant. It varies. Okay, so there's the definition of chase demand and level capacity is in the FTEs. It's in the FTEs here, and it's not in the it's not in production. Okay, well that's all I have for this lecture of aggregate planning as an introduction, level 1, level 2, level 3. I hope this helps between the now and the next time that I see you. I want to urge everyone to take care. So take care next time I see you.